Okay, so a wonderfully small audience, that's good. I'll try and keep it reasonably brief. I do tend to go off on tangents, so if I start straying too much, I'm sure I'll be pulled back into line. I'm between you guys and a drink, and I want one as well, so I probably won't mess around. Title of this talk, as I've said here, Erlang on OpenVMS and in the HP cloud. It's kind of a brief overview of what HP is wittingly and to some degree unwittingly doing with Erlang. So first up, we're going to do a whistle-stop tour, really, of some work I've been doing to port the Erlang VM and OTP and so forth to the HP OpenVMS operating system. This is a totally alien operating system, really, as far as Erlang was previously concerned. We'll talk about how we've got that going, and then we'll have a little bit of a look about how we're using Erlang, as I say, somewhat unwittingly within the HP public cloud, which has yet to be launched, but we'll come to that. Bit of an abstract here about what we're going to discuss. I mean, I've already mentioned all of that sort of nonsense. Probably, you know, there's some background here, really. I started using computers really at university back in 1987. The first computer I used was back in those days, Digital Equipment Corporation, OpenVMS, VAX system. So I have fond memories of using VAX and the OpenVMS operating system. And over the years, I've made something of a habit of porting any random piece of open source software I can find to that operating system, almost as a bit of a hobby. Some background about me, mostly boring rubbish. I've been doing this sort of thing for, well, actually about 20 years now. I live down the bottom of the world in Christchurch, New Zealand, hence the strange accent. Probably the most important bit there is the stuff down the bottom that in my spare time I enjoy listening to music, playing the guitar and drinking beer, preferably cheap Australian lager. So I'm hopeful that I'll find some of that later this evening. Otherwise I'll have to settle for some of that American rubbish. My introduction to Erlang. So first up, remember this face. You know, if you ever bump into this man, trouble. This is my good friend Chris Brown, and my introduction to Erlang really had sort of started, well, a couple of weeks prior to Chris and I being on a consulting adventure. I call it an adventure because whenever you go anywhere with Chris, there's always something strange happens. And on this particular situation, we got a good slice of American culture where we bumped into drug dealers on a train after dark going between Sacramento and Folsom. On that same train, we also bumped into a pimp who was trying to ply us with his wares, so to speak. We got absolutely hammered at a nice little bar called Scarlett's Bar in Old Town Folsom. Bad things happen when you go out with Chris. But anyway, at that time, Chris was the director of OpenVMS strategy for HP, for the HP OpenVMS operating system. And I was talking to him as we were finishing up that trip in the San Francisco British Airways lounge. And I was telling him about Erlang and things like that. And he thought this sounded pretty cool. And he basically challenged me to get it working on OpenVMS. So it's all his fault, really, that I'm here today, I guess. Chris has since left HP and runs his own consulting business and runs a successful little cafe in Newcastle. If you're ever up that way, pop in and say hello. Objectives of the talk, as I've said, to just talk you through the work I've done to port Erlang to the OpenVMS operating system. I use the word legacy there. A lot of people don't like the word legacy. Well, HP people don't like the word legacy in front of OpenVMS. It hasn't been around quite as long as Unix. The first version came out around 1997, so it has been around for a while. Just going to talk you through the process of porting Erlang to a foreign operating system environment, some of the results obtained, and then, as I say, we'll talk about the cloud stuff. Feel free to ask any questions along the way. So, before we can really talk about porting Erlang to OpenVMS, we sort of have to talk a little bit about what this weird and wonderful operating system is. As I say, first version of OpenVMS came out in 1997, a few years after the first version of versions of Unix. I started work for Digital Equipment Corporation on February the 12th, 1992. I'd finished my PhD and I had no money. I needed a job. I took a contract for 3 months and I've been there ever since. Since that time, DEC was purchased by Compaq in 1988. I felt a little bit upset about that, you know, Digital Equipment Corporation being purchased by a PC manufacturer, but there you go. Compaq was subsequently purchased by HP. When was that? 2002. And in all that time, the OpenVMS operating system has persevered and new versions have come out and so on and so forth. It's also moved across a number of architectures. In the old digital days, it was on VAX and Alpha, and now it runs on the Intel Itanium 64-bit processor. As I mentioned before, it's a totally un-Unix-like operating system from a user perspective. There have been some efforts over the years to sort of create shells and so forth to make it look a little bit Unix-like, but they've never really come to too much, and they're not really all that good in my opinion. As a consequence of this, it can be quite challenging at times to port open source code to OpenVMS. Okay. It is a very widely used operating system, strangely so. I suppose, I'm not sure how many of you here have heard of the operating system, but there are something like 300,000 odd systems out there supporting millions of users across a whole raft of different industries. One that's kind of close to my heart, work I've been doing in recent years, is it's heavily used within fairly high-end financial services organisations. Shanghai Stock Exchange, for example, runs on OpenVMS. Deutsche Bank, in terms of all their foreign currency exchange, runs on VMS. I could list many, many more sites. In fact, probably the vast majority of large stock exchanges around the world still use the HP OpenVMS operating system. One thing that I should have mentioned there, as far as doing development and so forth on OpenVMS, you've got most of the stuff you need. In fact, it's very rich in terms of system calls and useful library functions and things like that. Supports most compilers of various assorted languages, 3GL compilers, C, BASIC, Pascal, Fortran, COBOL, etc. Runs Java quite happily, all sorts of good stuff like that. So you've got pretty much all the tools you need really to port open source software to the platform. But there are some fairly significant differences that we'll talk about soon that need to be addressed one way or the other. My motivations for this work, now I've got two slides on this. One of them is me with my HP corporate hat on, where I say things like, I wanted to port Erlang to OpenVMS to make available to our customers this exciting product, and all sorts of stuff like this. But if you think about it, there are a couple of sort of logical reasons for wanting to run something like Erlang on OpenVMS. There are actually a lot of parallels. OpenVMS is known for its scalability, performance, incredible levels of fault tolerance. It's a highly fault-tolerant, highly available operating system. There are actually quite a few parallels that sort of make the combination of Erlang and OpenVMS a good one. If I actually, however, sort of look at it from a personal perspective, the reality is that I wanted to get an implementation of AMQP, the Advanced Message Queuing Protocol, working on OpenVMS because there were opportunities for me personally, if I did that, to actually get some cool consulting assignments in interesting places around the world. Reason being that a lot of our financial services customers who use technologies like MQ series and other such older message queuing technologies are looking at moving towards AMQP as their preferred message queuing implementation. So I was therefore very keen to get an advanced message queuing protocol implementation up and running on OpenVMS. We could then talk to our financial services customers about replacing their older, more proprietary message queuing software with some open source AMQP implementation. I initially started off here with a little piece of software, well, it's not that little actually, called OpenAMQ, which is was actually the very first AMQP implementation written by a company called IMATIX, who are based in Belgium. But for various reasons, which I won't go into, maybe later on over a beer if anyone's interested, IMATIX has pulled out of the AMQP working group and no longer support that software, which is a bit of a shame. It was a nice piece of work. They're focusing their attention really on ZeroMQ, which is a slightly different messaging technology. Subsequent to that, I discovered RabbitMQ, which is written in Erlang. This is an open source AMQP implementation that I discovered written in some funny language called Erlang. So getting back to slide number 5 when I was talking about my friend Chris Brown and I was telling him all about this, basically with Chris's sort of giving me a dare, I bet you can't get Erlang working on OpenVMS, plus the fact that this stuff looked pretty cool and interesting and had quite a nice name, I thought, well, let's give it a go. So the challenge had been set. What I'm going to go through now is the basic approach that I take to porting this sort of software. I mean, as I say, as far as open source code goes, I mean, OpenVMS it's different to just about any other operating system I can think of. In fact, it is different to any other operating system I can think of in terms of command line interface. Just the way the whole operating system works is very, very different. So you can face quite a number of challenges when you're porting open source C code or whatever to OpenVMS, even from things like build tools, Differences in C runtime library is quite often a big one. Things like that. The way the file system works is very, very different from Unix. So there are all these sorts of things that need to be taken into consideration. If you look at something like Erlang Beam, you're dealing with something like 400,000 lines of pretty complex code. So trying to get this volume of code ported across to OpenVMS, you know, is not an afternoon hack over a few ales. It's a fairly arduous exercise. So I was trying to think, well, how am I going to approach this? I'm not going to be beaten. Chris has dared me to do this. I'll sort it out. So I tried to devise an approach to doing it. I used an approach that I've commonly used, which I'll talk about in a minute. But generally, when you undertake these sorts of exercises, there are a few things that you need. Apart from the sort of knowledge that I've indicated there around knowledge of the operating systems like OpenVMS and Unix, differences between C runtime libraries and so on and so forth. Patience is useful, something I sadly lack. Alcohol is incredibly helpful, also incredibly detrimental if you have too much of it. And if at first you don't succeed, go and put some loud music on and sort of get frustrated for a while and calm down and come back to it. I suppose probably I did this work over a period of several months, doing a little bit here, a little bit there. Sunday afternoon, tappity tap tap, let's just do a little bit more, get a bit further, things like that. In fact, this is me on holiday with my family in Mallorca of all places. So basically in front of me there, my wife is standing right beside this gorgeous swimming pool. The children were in the swimming pool and I'm working feverishly on my port of Erlang to OpenVMS. As you can see, I've got the essentials. There's a couple of ales there being consumed or in the process of being consumed. There's a packet of chocolate biscuits, similarly partially consumed or whatever. So I worked fairly hard on this for some period of time to get it working. Basic approach I took was to actually, first of all, build Erlang on a Unix system. That just happened to be Solaris, doesn't really matter, could have been something else. And I captured the output of the build process. So this is the configure script and running make and so forth. Just directed that output to a file so I could examine it later at my leisure. To keep things reasonably simple, I decided initially to leave a number of options out when running the configure. I didn't bother building Erlang with full SMP support. I've built that back in now. That's fine and dandy. I left out things that I knew just simply would not work on OpenVMS without some additional effort, things like the WX Windows bits and pieces or the ODBC bits and pieces, things like that. I would have had to have first ported some other things to VMS before I could get those components going. And like I said here, you could come back and revisit those things and incorporate them into the build later on. First thing you've got to do really is looking at the output of the log from the Unix system, figuring out how am I going to convert this into a series of commands on OpenVMS to build this piece of software. You're starting out, you haven't got things like GCC on OpenVMS. You've got the HP OpenVMS C compiler, which doesn't work anything really like GCC in terms of command line options and so on and so forth. So one of the first things you've got to do is have a look at, well, what options are being specified for GCC in the build here on Unix? How do I have to translate those sorts of things to something that the OpenVMS compiler understands? These include things like specifying names as is and shortened. What that means is, well, OpenVMS generally doesn't like function or variable names that exceed 31 characters. And unless you tell it otherwise, it converts all variable and function names to uppercase when doing the compile. So you tend to want to specify as is to preserve case, and when you specify shortened, it does some jiggery pokery with CRCs and things like that, but it doesn't bleat and moan about long function and variable names. So those sorts of things need to be addressed, basic compiler options. Sorting out include paths, they're specified quite differently on VMS to Unix. Linker command options, so on and so forth. How we deal with archive libraries and shared libraries are slightly different on OpenVMS. So just dealing with those top level things first is like the first step that you would do. Then, you know, like any good open source piece of software, you typically end up, the configure script generates a .config file which contains all sorts of interesting bits and pieces, #ifdef this, #ifdef that, and so on and so forth, depending on whether you have certain include files, whether you have certain functions, and so on and so forth. So it was a case of going through that and identifying the differences between the initial Unix platform used for the first build and what OpenVMS does and does not have. So an example that I'll talk about a little bit further on, OpenVMS doesn't have a Unix-like fork function, so you would have to modify the config file to basically say, no, we don't have fork. Things like that. obviously you need a reasonable knowledge of the OpenVMS C runtime library in order to deal with that. So on and so forth. As I said before, VMS doesn't have make, but it does have some equivalent tools. But I tend to prefer to work just basically with a series of commands to do these builds, because you just tend to have a far better picture of exactly what's going on. I could flick it back into something that looked a bit like a makefile later on. Once you're sort of starting to make progress, you've figured out basic compiler options, you're actually starting to get some of the code to compile, you're getting some compiler warnings and things like that maybe, but generally speaking your build is starting to look good. The next pass is to actually look for little quirks in the code, like for example on OpenVMS the fcntl call, C runtime library call, cannot be used to toggle blocking and non-blocking on sockets. So you've got to go and modify the Beam C code to handle that situation. #shift-def OpenVMS, then use IOCTL instead of fcntl and so on and so forth. I'll talk a little bit more about fork exec sequences later, but they're a little bit trickier to handle because, as I say, the operating system does not support a Unix-like fork. Dealing with the file system was probably the trickiest thing to do, and I had to make some decisions here. Basically what I ended up doing from an Erlang, or more to the point from an OTP perspective, was basically convincing OTP that OpenVMS is simply a variant of Unix. By doing that, I completely negated the need to have to make wholesale changes throughout all the OTP code. So if you fire up Erlang on OpenVMS and you type os:/type, etc., it will say Unix, OpenVMS. It just thinks that OpenVMS is another flavor of Unix, and for the most part, OTP doesn't care what flavor of Unix you're using, except in a small number of cases. So that simplified life as far as having to make any changes to the OTP code was concerned. I think probably I had to make maybe 3 or 4 changes to the OTP code in order to get this all working. The vast majority of the changes were in the Beam C code and things like that. Just a summary of the technical issues. Like I say, there's no Unix-like fork. VMS supports vfork, but that doesn't do some of the stuff that fork does. Luckily, fork is only used in about 4 or 5, maybe 3 or 4 places within the Erlang C code, and it's really only used to kick up auxiliary processes, and then you end up establishing pipe-based communication between the parent and the child and things like that. So it wasn't actually too hard in the end, after some initial degree of panic, it wasn't actually too hard in the end to figure out how to replace those fork exec sequences with something that would work on VMS. There are some consequences of doing that, but they're not significant. I talked about fcntl. The other thing is there I've got poll and select. Those 2 functions on OpenVMS only work on sockets. Some of the code within Erlang, within the VM and so forth, expects to be able to poll things other than sockets. So as a consequence of that, I had to write wrappers around those functions to address the requirements to poll other interfaces and so forth. And that's probably had some performance implications. As it stands, poll and select aren't very efficient on OpenVMS anyway, and I've gone and added another layer of hackery on top of that, which has probably slowed it down even further. File system differences. Traditionally, OpenVMS has had basically an 8.3 file system. You couldn't have any special characters, you couldn't specify multiple periods in a file name. The syntax is completely different to Unix. You've got square brackets and things like that instead of slashes and so on and so forth. Luckily, a few years back, we introduced what's called the ODS5 file system, which does support Unix-like syntax. You can have special characters, you can have mixed case file names of nice long length. You can specify slashes and things like that, and the operating system knows what to do about it. So one caveat with regards to this Erlang port to OpenVMS is that you must use an ODS5 file system, and any customer I encounter these days that's using ODS2 probably needs to be re-educated. You get the same issues obviously with Java as well. You can't use Java on VMS with ODS2, it just doesn't work. Testing the port. Now, obviously I could have pulled out, there's a fairly good comprehensive test suite provided with the Erlang distribution, but my main objective, if you recall, was to get RabbitMQ to get an AMQP implementation up and working on OpenVMS, so I thought blow it to that test suite, let's just see if we can get RabbitMQ up and running. It's a fairly sophisticated piece of Erlang code. It's about 35,000 lines of code. It uses lots of bits and pieces with an OTP. Much to my amazement, I had to make one change to the RabbitMQ code in order to get it working on OpenVMS, and that change wasn't essential. It was only a warning when RabbitMQ started up. And basically there's a little bit of code within the RabbitMQ product that tries to figure out, uses ulimit to try and figure out how many sockets and file descriptors and things like that it can use. There's no such thing as ulimit on OpenVMS, so I just had to modify the code to say, well, look, if you're on the OpenVMS platform, then this is how many sockets you've got, kind of thing. Also did some more testing with yours and CouchDB, and they both work pretty well, actually. Again, no changes really required to the Erlang code at all in order to get it up and running on this alien platform once I'd actually got Erlang up and running. But we'll just take a little bit of a look at RabbitMQ. For those of you who don't know, RabbitMQ, as I said before, is an Erlang-based implementation of the Advanced Message Queuing Protocol. It's probably far and away the most popular implementation of AMQP, and you know, if I really felt like it, I should have worn my RabbitMQ t-shirt and prostituted myself as being an advocate for the guys there. They're a good bunch based in London, and they always buy me beer whenever I'm in town, so I'm happy to say nice things about them. They also do have a very good product. Essentially, RabbitMQ provides an AMQP broker, entirely written in Erlang, not a scratch of C code or anything like that. It's 100% Erlang. Very, very scalable. You've got gateways for an assortment of different protocols, and the guys support client APIs for various languages, and the open source community has created client libraries in numerous other languages. The guys were bought by VMware in 2010. They now have a very nice salubrious office in London there, somewhat better than their previous abode. But anyway, so here we are. This is what's called a DCL command procedure, the equivalent, I suppose, of a Unix shell script. DCL command procedure to boot up the RabbitMQ application. Okay, so at the top we're defining a few environment variables. Under VMS these things are referred to as symbols. The bit there which I've said you really don't want to know what this is for, I'll tell you. Basically I'm defining what's called a logical name, which is again a little bit like an environment variable, $C$FD locking. Sadly, still to this day, there are a number of calls within the C runtime library that are not thread safe, particularly around I/O. Defining that logical name ensures a higher degree of thread safety. So that's kind of why that's there. Next up, the third yellow blob down there. Normally when you run something on OpenVMS, you type run followed by the name of the program you want to run. Of course, when you're running Erl, you need to specify a whole pile of command line options, so we need to create what's called a foreign command, and then the fourth blob down, there we go, we're running Erlang with RabbitMQ. We're specifying a few paths to various bits and pieces, and a whole raft of other options. There's too many double quotes in there for my liking. Some of them aren't necessary, but I'm just being very, very careful about preserving case, to be honest, because in some situations, depending on how you have your login environment set up, the case of some of these options might have gotten converted to uppercase, shall we say. But essentially, fairly standard stuff from an Erlang perspective. And we boot it up, and we get these four processes. The endpoint mapper daemon I'd already started before I did this. The show system command, as illustrated up the top, is like the equivalent to VMS of a PS command on Unix. It lists the running processes on the operating system. So you can see we booted up RabbitMQ. We've also got a pile of sub-processes with my name in them against the name of those particular sub-processes. You can probably guess by looking at the amount of I/O that's been done by process ID 2177 that's the main beam process, and you'd be right. This is running a few tests through RabbitMQ. Way out the far side there you'll see little MS. So that M basically means that is a multi-threaded process, so it can run across multiple cores and all sorts of fancy stuff like that, which is good. But if we have a look at what those four processes are, not surprisingly we've got Erl exec, which is basically what gets run when you type the Erl command, and it boots up Beam. One thing I'll point out here, you'll notice after the beam.exe there's a semicolon 300. OpenVMS has what's called a versioning file system. It keeps incrementing the version number every time you create a new version. You can stop it doing that and rename things and so on and so forth. But you might take from beam.exe version 300 that it obviously took me a while to get all this stuff sorted out, quite a number of builds before I actually got something that worked properly. It's probably a slight exaggeration because I've just made refinements over time, but it certainly was at a high number before I actually got things working. And the other couple of processes there are standard things that get kicked up when you boot up a substantial Erlang application. We've got the inet get host process, which is used to do name service lookups, and child setup.exe, which manages startup of other child processes. So these all get kicked up on our operating system, and we're all looking good as far as our Erlang environment goes. So getting something like RabbitMQ going has given me considerable confidence that the port is in good shape. Is it totally bulletproof? Is it 100% right? No, there's still quite a lot of work to be done. One of the main areas there would be around performance. So if, for example, we look at the performance of RabbitMQ on VMS versus a comparable Linux system, you've probably got a disparity of a factor of 3 or something like that in terms of performance. Now, there are multiple reasons for that. I talked about poll and select before and the layer I put on top of them. Obviously, this is a networked application. And also being at Rick Reed's talk before was quite insightful, and I have to get his slides because one of the things I've been thinking is that there's obviously a lot of tuning that can be done here, TCP layer at the kernel level and so on and so forth. I mean, at the end of the day, you know, this is essentially a just get it working port of Erlang to VMS. I haven't really done any operating system specific tuning at this point. And I would like to think that with a bit of effort there, I could probably reduce that performance disparity and get pretty close to the sorts of figures I'd expect on a Linux platform. I mean, that'll be quite a bit of work, but we can get there. I've done testing around bits and pieces like SSL, clustering, amnesia, and things like that, and they've all worked out of the box. No additional effort required on my part. It just worked out of the box as I expected. One serious limitation I've got at the moment, you know, which almost seems farcical in this day and age. At the moment, Beam's constrained to around about a gigabyte of memory. Reason for that is, whilst OpenVMS supports 64-bit or you can build applications 32-bit and so on and so forth, there's all sorts of funny stuff that goes on with the operating system around process quotas, and there are restrictions there. But basically what I've got to do to overcome that 1 gigabyte heap limit is to build Erlang using 64-bit pointers, which will basically give me unlimited, to all extents and purposes, memory on the system. Bit of work required to do that, but probably not too bad. What I have found, as long as I keep an eye on that memory restriction, things like yours and RabbitMQ and so forth are very, very stable and generally work pretty well. So I'm quite happy with that. We've had a bit of interest. As I say, I mean, this was mostly done from the perspective of getting an AMQP implementation working on VMS, so we've achieved that. We've had some inquiries from a couple of chip manufacturers. OpenVMS is quite heavily used within that space, a European rail company, and we're working actively to try and generate interest in several accounts. There's a large what would you call them, I suppose, a large telecommunications company here in the United States that we're talking to about using Erlang and RabbitMQ on OpenVMS. A certain unnamed security agency has exhibited interest in Erlang on OpenVMS. Strangely enough, they wouldn't tell me why. That's their prerogative, I guess. And we've also had interest from a number of hobbyists. There's quite a large hobbyist community out there. Future plans, well, I want to get rid of that 1 gigabyte limitation because that's just silly, and that's a real handbrake. So I need to do a lot more work on the 64-bit pointer build. There are still some I/O issues, particularly around flushing and things like that probably require a few changes at the OTP layer more than at the C code layer. I would actually like to do the job, I've said properly / better. I mean, I would say that the port I've done to date has been a little bit hackerish. I maybe need to sort of retrace my steps and do it in a more structured fashion, shall we say, with Erlang 15 or whatever. Depending on the level of interest generated, I'd also like to see if we could actually get our engineering guys involved in this work, and much as they did some years ago around getting Java onto the OpenVMS platform, I'd like them to take the lead in terms of Erlang on the OpenVMS platform. And good friend John Apps, who now lives in the States, and I probably need to actually do a little bit more promotion. John's got a blog site there at that URL that sort of gives you latest developments on what we've been up to in this space. But we probably need to, just do a little bit more marketing, I suppose. Okay, so I'm going pretty quickly because I'm thirsty. A little while back I used to work for HP Enterprise Services. A little while back, start of the year, I switched over to working for HP Cloud Services. HP Cloud Services are charged with basically getting HP's public cloud presence up and running. And at the moment we're in private beta and we're not too far away from going public, maybe a month or two I think. What's there at the moment is looking pretty darn good. I mean it's really, at the moment, the focus has been around the infrastructure as a service type stuff, getting all the tin there, getting in place teams to sort of feed and water all that hardware and so forth, and making sure it's stable, sorting out the software around deploying the infrastructure and managing it and so on and so forth. Key point here is that strategic decision was taken a little while back to go with OpenStack, and I'll talk more about that soon. It's probably HP's fastest growing business unit. I mean, we're not anticipating cloud services to be the major money spinner for HP, but if you look at sort of combining the might of the organisation from, in terms of all the sales guys that are out there, in terms of all the different business units and so forth, we'd like to see it becoming a fairly substantial part of the organisation and something that might supplement other sales efforts and so forth across the enterprise. The team that I work for is spread all around the place. There's teams in Bristol in the UK and in Galway in Ireland doing some pretty good work. I report to folks up in Seattle, and we've got guys in Cupertino, Colorado and elsewhere. We've got me in New Zealand, and we've got one guy in Australia as well. This is a lot of words by our leader, Singh, who's a very interesting character, and he's actually been very, very instrumental, I think, in terms of actually really accelerating the pace of HP's public cloud offering. It was Barry that made the decision to switch to OpenStack. I mean, HP had internally been beavering away within labs and so forth, developing its own cloud deployment management software, whatever you want to call it. This was really taking a long time. It was looking very, very good, but in terms of getting something out there, we really want to do that quickly. I mean, we're a little bit behind the game already, I suppose, and Barry wanted to sort of pick up the pace. So he made the big call to go with OpenStack on that. You can read the words up there. I mean, we're not looking to take on the world, as I say. I mean, we're really looking to make this a strategic component of HP's overall suite of offerings. If you look at OpenStack, OpenStack is a piece of open source software for, as I say there, building public and private clouds. It initially started out as a project between NASA and Rackspace, and they decided to open source it a while back. Since that time, its interest in OpenStack or adoption of OpenStack has really taken off, and at last call there were something like 155 companies involved in the OpenStack project or using the technology in one way or another. HP is now one of those companies. And I think probably where we're at in terms of our private beta deployment of our cloud infrastructure, we're probably almost pushing OpenStack further than just about anyone else. I can't say that categorically, but there's some pretty scary numbers coming out in terms of numbers of virtual instances and so on and so forth. I won't bore you with all the bits and details of the components of OpenStack, but the key one to note here is a thing called Nova, which is the bit of OpenStack responsible for orchestrating and managing all your virtual machine environments and so forth. The reason that's important is because that's where Erlang fits in. Essentially, while we don't think about it, at the end of the day, none of this stuff within OpenStack would actually work without Erlang. So, like I say there, Erlang is absolutely critical to the operation of HP Cloud. It's absolutely critical to the operation of anybody's cloud who are using OpenStack. The reason for that is when the guys originally put OpenStack together, they made the choice to use our old friend RabbitMQ, that little product again, and the reason I'm now with HP Cloud Services is because they seem to think I know something about that product, is that as I say, the guys decided to use RabbitMQ as the means of communicating between all the various processes that make up the OpenStack Nova component. And of course, RabbitMQ sits on top of Erlang. So at the end of the day, Erlang is ultimately responsible for the success or failure of HP Cloud, or indeed any other OpenStack-based cloud deployment. It's managing, huge numbers of inter-process communications and many links across hundreds, eventually thousands of servers. One of the guys in Bristol did a calculation a few weeks ago, and I think he was looking at something like 50,000 connections to RabbitMQ/Erlang for just one segment of the private beta cloud that we've currently got out there. We've actually done a little bit of refinement and pulled that number down to about 35,000. There was some dodgy connection pooling going on that meant we were probably taking out more connections than we needed to. But the numbers are certainly starting to stack up. And I've been fielding questions from the guys around RabbitMQ and Erlang, just how far can we push this thing? And I mean, needless to say, I keep going back to them and saying it's not an issue, it's not an issue. But at the end of the day, I think we're probably hitting a point now where some serious thought needs to be given to tuning at the OS level, tuning at the Erlang level and things like that. We've largely been running with vanilla configurations to date, and it's not going to hold up for much longer, I suspect. The interesting thing is that much like me, many of our architects within the cloud services team seem to have developed a liking for RabbitMQ, and one of the things we're doing after we've sorted out all this infrastructure as a service and got the basic cloud stuff out there for the world to use is obviously we want to create some money-spinning applications, provide some software as a service type stuff running on HP Cloud that customers can use and pay us money for using. And our architects have actually latched on to using RabbitMQ and hence Erlang for all sorts of fancy stuff like that. We're looking at message queuing as a service, for example, monitoring as a service. Bock, which isn't actually a service, Bock is like an add-on that we've created into OpenStack for block storage, and there's some seriously good IP that I can't really talk about that's going on within that. And again, the guys that have created Bock, the team in Ireland, again, are using RabbitMQ and Erlang for all the inter-process communications and so forth. So just a couple more slides on some of these services we're developing. Really, first up around monitoring. I mean, the key thing in terms of setting up our cloud infrastructure is obviously we want to know what's going on, monitoring our infrastructure, monitoring the hardware, operating systems, things like that. So we're putting in place a solution that looks a little bit like this with collectd and AMQP plugin, all talking to our friend RabbitMQ and Erlang again, and data going off to various places to be aggregated or for alerting or whatever. And the other one, which is probably more my area of expertise, I suppose, is message queuing as a service. I won't go too much into this really, except for the first point there to say what it is, which is essentially middleware deployed within your cloud using a software as a service model. And VMware are already doing this with RabbitMQ, and essentially we're looking at doing something similar within our cloud infrastructure environment. And that's an incredibly quick talk for me. I must be really thirsty. We've talked about getting Erlang up and running on a totally alien operating system. Some of the things that I talked about there I think would be relevant to porting Erlang to some other alien-like operating system, maybe a mainframe environment or something like that. There'd be similar considerations that you would have to make. And as I explained, sort of almost unwittingly, Erlang is critical to the operation of not just HP's but a number of other organisations' cloud offerings. Any questions?
I missed the start of the talk, so apologies.
That's all right.
Is OpenVMS sold commercially still?
Oh yes. Yeah. So I mean, it's still developed, supported. So OpenVMS 8.4 came out around 2010, and 8.5 is in the pipeline. There's absolutely no issue there whatsoever. Yeah.
I was a VMS guy forever and ever through a lot of my career, so it kind of warms to see this. But I've been out of it for a while. Is Itanium the only architecture that you're on
No, we're still on alpha, and there's still limited support for alpha.
Can I run this on the VAX emulator?
No, you wouldn't even be able to build it on VAX, unfortunately. The C runtime libraries are just too old. But in terms of where the operating system is at on alpha and Itanium, they're parallel. So I have built this quite happily on alpha, and it will work. Doesn't work quite as well as it does on Itanium. But essentially, as I say, if you've got OpenVMS 8.4, if it's alpha or Itanium, same beast.
Having ported a lot of stuff back in the day, I can feel your pain.
Well, the C runtime library has gotten a lot better over the years. So you might be surprised if you went back and had a look now. I mean, just in recent times, for example, there's now semaphores and all sorts of other stuff like that that just hadn't been in there for a long, long time. So, it's almost at the point where anything you could find in a standard Unix or a standard Linux C runtime library is in the DEC C runtime library. That doesn't necessarily mean those functions work exactly the same way. You've got potentially constraints around quotas if you're setting up pipes or a whole lots of random things like that. And sometimes functions appear in different header files than they would on a standard Linux implementation or whatever. But in terms of completeness, it's not looking too bad. I know that engineering are working on the fork carry-on, but they might have almost bitten off more than they can chew there, because if you know something about the way the OpenVMS operating system works, I mean, you're really getting right down to the fundamentals there. It's just not going to work. Yeah. Any more? No. Cool. Thank you.